Just when humanity thought it had the universe figured out, the cosmos quietly proved us mistaken. Music, for ages, the expansion of space and cosmic dust acted like locked gates, obscuring the true mechanisms behind creation, the first galaxies and the earliest stars. We looked up, yet we were always missing the greater part of the story. Then, on Christmas Day 2021, a telescope different from anything ever built unfolded in the void. It was designed not merely to look farther, but to see in a completely different way. Since becoming operational, the James Webb Space Telescope has pierced through ancient veils, revealed impossible worlds right next door, watched planets and stars being born in real time, and uncovered galaxies that simply should not exist so early in cosmic history. In doing so, it hasn't just provided breathtaking images. It has compelled scientists to stop, question, and in some instances admit that the rules we thought ruled the universe might no longer apply. This is the story of how a single telescope didn't just alter astronomy, it stopped the world. Music, for as long as we have studied the night sky, our view of the cosmos has been fundamentally incomplete, not due to a lack of curiosity, but because of two massive barriers woven into the very fabric of space. The first is cosmic dust, vast clouds of microscopic particles scattered throughout galaxies, absorbing and scattering visible light, hiding whatever lies behind them like an eternal fog. The second barrier is the expansion of the universe, which stretches light as it travels across vast distances, shifting it out of the visible spectrum and into infrared wavelengths that traditional telescopes simply could not see. Music, these two effects worked in tandem to keep the universe's deepest secrets buried. We could not observe the earliest stages of star formation, we could not see the first galaxies, and we could only guess at what was occurring inside dense cosmic nurseries. For centuries, astronomy was forced to work around these limits, constructing theories based on fragments, indirect evidence, and incomplete views of reality. That changed with the launch of the James Webb Space Telescope, a $10 billion partnership between three space agencies, engineered from the ground up to conquer both of those ancient barriers simultaneously. Equipped with ultra-sensitive infrared detectors, Webb was built to see what dust hides and to capture light stretched by billions of years of cosmic expansion. Music, once it became fully operational in July 2022, the effect was immediate and profound. Webb was no longer restricted to photographing the universe as it appears in visible light. It revealed a universe that had always been there, but had never been accessible. Faint, distant objects emerged from the black. Structures hidden behind dust became visible, and the earliest chapters of cosmic history began to come into focus. This was not just an incremental upgrade over past telescopes. It was a fundamental shift in perspective, allowing humanity to finally observe regions of space and time that had been completely off-limits before. In lifting these cosmic veils, James Webb didn't just add new data to astronomy. It opened an entirely new window onto reality itself. Music, when James Webb turned its gaze toward our own cosmic backyard, the results were quietly shocking, because even the most familiar planets transformed into something almost unrecognizable. Neptune, long famous for its deep blue hue and visible light, appeared ghost-like and ethereal through Webb's infrared eyes. The reason was simple but profound. Methane in Neptune's atmosphere absorbs most infrared light, leaving the planet itself subdued and dark. Yet this apparent loss revealed an unexpected gain. With the glare reduced, faint structures that had always been hidden suddenly popped out with unprecedented clarity. Neptune's dusty rings glowed softly against the dark. High-altitude clouds stood out in sharp detail, and previously unseen ring arcs were revealed for the first time. Webb also captured images of 14 of Neptune's known moons, presenting the clearest infrared view of the ice giant ever recorded. What once seemed like a static, distant world became a delicate and complex system, reminding scientists that familiarity had masked complexity and that the universe close to home still held secrets, waiting for the right kind of light to uncover them. Webb's focus then shifted from planets born with our Sun to an object that did not belong to our solar system at all. On August 6, 2025, the telescope used its near-infrared spectrograph to study the comet known as 3I/Atlas, joining a global effort to observe this rare interstellar visitor. The goal was not imagery, but chemistry. Music. What Webb discovered fundamentally expanded our understanding of planetary systems beyond our own. The comet was found to be unusually rich in water vapor and carbon dioxide, with ratios among the highest ever measured in any comet. This composition revealed that 3I/Atlas formed in a distant star system, in a region cold enough for carbon dioxide ice to freeze naturally within its original planetary disk. By directly sampling the material of this comet, James Webb demonstrated that the basic building blocks of planets, and potentially life, are not unique to our solar system. The same chemical processes that shaped our own planetary neighborhood appear to be widespread across the galaxy. In doing so, Webb transformed a single icy object into powerful evidence that the architecture of planetary systems and the ingredients that build them may be universal rather than rare. Music. When James Webb turned its infrared vision toward regions long studied by astronomers, it revealed that many of the universe's most iconic structures had been hiding their true nature in plain sight. The cosmic cliffs within the Carina Nebula and the famous pillars of creation in the Eagle Nebula were already familiar thanks to Hubble's visible light images. Yet those views only showed the outer silhouettes of towering clouds of gas and dust. Webb changed that completely. By observing in infrared wavelengths, it pierced the thick dust that once blocked our view and exposed thousands of previously unseen stars embedded deep within these structures. In the pillars of creation, Webb's NIRCam revealed newborn stars glowing as red points just outside the dense columns. Their light was shaped by energetic hydrogen molecules excited by shock waves and plasma jets. These stars, only a few 100,000 years old, appeared like pulses of activity erupting from what once looked like static stone pillars. Music. In the cosmic cliffs, Webb captured razor-sharp details of turbulent gas being actively carved and eroded by intense radiation from massive young stars nearby. What once appeared as calm, sculpted formations were revealed to be dynamic, violent environments where gravity and radiation continuously reshaped the landscape. For the first time, astronomers could directly observe stellar nurseries as active construction sites rather than finished monuments. Webb's revelations did not stop at hidden stars. It showed that stellar birth is not a gentle process, but an explosive one. In a distant region of the Milky Way known as Sharpless 2284, roughly 15,000 light-years away, Webb detected a massive protostar up to 10 times the mass of our Sun, unleashing enormous bipolar jets of radiation and gas. These jets, driven by powerful magnetic fields, were launched at hundreds of kilometers per second, stretching across an astonishing 8 light-years and plowing through surrounding molecular clouds like a cosmic snowplow. The result was a rare and spectacular Herbig-Haro object, where the jets collide with nearby material and create glowing structures that mark the violent birth of a massive star. What made this discovery even more significant was its environment. The protostar formed in a low metallicity region at the edge of the galaxy, closely resembling the conditions of the early universe, offering critical clues about how the first massive stars may have formed billions of years ago. Music. Webb also revealed the next stage of creation. Around the young exoplanet CTB, located 625 light-years away, the telescope detected a circumplanetary disk, a dense ring of material where moons are likely forming. Using its MIRI instrument, Webb measured the disk's chemical composition and found it to be rich in complex carbon-based molecules such as benzene and acetylene, sharply contrasting with the water-rich but carbon-poor disk surrounding the host star. This direct observation of a moon-forming disk provided the clearest evidence yet of how planetary systems organize themselves, showing that stars, planets, and moons emerge through interconnected processes that Webb is now witnessing as they happen. Music, even with all of its power, James Webb still faces a fundamental limit: light itself. The earliest light in the universe was released only after space became transparent, hundreds of thousands of years after the Big Bang, meaning anything before that moment cannot be observed directly with light. But physics provides a workaround. Webb takes advantage of gravitational lensing, a phenomenon where massive galaxy clusters warp space-time and act like cosmic magnifying glasses. When Webb observed the galaxy cluster RxJ 2129, located about 3.2 billion light-years away, it used this natural lens to study objects far beyond what would otherwise be visible. In 2023, Webb captured a supernova explosion hidden behind this cluster. But the telescope didn't see it just once. The warped space-time split the light into multiple images of the same event, appearing as echoes across time. Because each path the light followed had a different length, the explosion appeared at slightly different moments. By measuring these time delays, astronomers could calculate enormous cosmic distances with extraordinary precision. This data is critical for refining the expansion rate of the universe, known as the Hubble constant, an area where current measurements disagree. In this way, Webb was not just looking farther than ever before. It was turning gravity itself into a scientific instrument, extracting information from distortions in space and time. With the help of gravitational lensing and its infrared sensitivity, Webb pushed its vision to the very edge of the observable universe, into an era known as the Cosmic Dawn. As part of the JADE survey, Webb's NIRCam and NIR-SPEC instruments identified galaxies whose light had been stretched deep into the infrared by the expansion of space. One discovery stood above all others. A galaxy later named JADE's GS Z14-0 was confirmed to have a redshift of 14.32, meaning Webb was seeing it as it existed just 300 million years after the Big Bang. According to the prevailing lambda cold dark matter model, galaxies at this epoch should be small, faint, and only beginning to form their first simple stars. JADE's GS Z14-0 was none of those things. It was massive, bright, and unexpectedly mature. Music, to reach that size so early, stars must have formed far faster and more efficiently than any current model allows. The existence of this galaxy, along with several similar discoveries, forces astronomers to confront a serious possibility that the foundations of modern cosmology may be incomplete. One proposed explanation revisits the idea of dark stars, hypothetical first-generation stars powered not by nuclear fusion, but by the annihilation of dark matter within their cores. Such stars could grow enormous, remain cool, and shine brightly in infrared light, exactly the kind of signal Webb is designed to detect. If these objects existed, they could help explain how galaxies like JADE's GS Z14-0 formed so quickly, connecting the earliest visible structures in the universe to the most mysterious substance it contains. Music. What the James Webb Space Telescope has done is not just show us beautiful images, and not even just expand our knowledge. It has fundamentally changed our position in the universe. By lifting the veils of cosmic dust and stretched light, Webb revealed that the universe is far more active, chaotic, and interconnected than we ever imagined. Familiar worlds like Neptune transformed under infrared light. Interstellar visitors like 3I/Atlas prove that the ingredients of planets and life are shared across the galaxy. And stellar nurseries, once hidden from view, were exposed as violent, living factories where stars, planets, and moons are being assembled right now. And then, at the farthest edge of what can be seen, Webb delivered its most unsettling message of all: galaxies that are too large, too bright, and too mature to exist so soon after the Big Bang, forcing astronomers to question whether the models we rely on truly describe reality. In doing so, James Webb didn't just answer old questions, it created new ones. And that is when science is at its most powerful. It showed us that the universe is not a finished story, but an unfolding one where even our best theories remain provisional. With more than 2 decades of potential discoveries still ahead, this telescope is only just beginning to reshape our understanding of time, creation, and our place among the stars. The world paused not because Webb looked farther than ever before, but because it revealed that the cosmos is richer, stranger, and more mysterious than we were prepared to accept. So, now I want to hear from you. Which of these discoveries surprised you the most? And what do you think James Webb should look at next? Let me know in the comments. And if you want to keep exploring the universe as it really is, don't forget to like, subscribe, and join me for the next chapter in this incredible cosmic journey. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.